Well, now we're going to ratchet it up a bit. Let's start off with the fundamental theorem of algebra, which would say that if a polynomial function is raised to a degree, let's call that degree n, then it is going to have that number of zeros, either real or imaginary. Let me say that again. If a polynomial function is raised to a degree of n, then there are going to be n zeros, either real or imaginary. Second, linear factorization theorem. If we are given zeros, we can write them as factors in this form, x minus c, where c is the zero. And then there is the conjugate root theorem and complex conjugates, which basically says that all imaginary zeros come in pairs with a positive and a negative. All right, let's see if we can put all this together. We're asked to write a polynomial function of least degree with real coefficients in standard form given with the given zero. So we got zeros of -3, 1, which has a multiplicity of 2, and 4i. Let's first write these as factors. So we would have x minus -3, which we would then recognize is going to be x plus 3. We've got x minus 1, and that's got a multiplicity of 2. And then we've got x plus 4i and x minus 4i. Now we've got to do a lot of foiling and multiplication here, because we're going to write the polynomial function given these zeros. Well, let's see. I guess let's start with x minus 1 times x minus 1. Let's foil that. All right, x times x is x squared. X times -1 is -x. -1 times x is -x. And -1 times -1 is +1. And when we combine like terms, we got x squared minus 2x plus 1. All right, let's hold on to that for a moment. Now, why don't we do x plus 4i and x minus 4i. All right, so we got x plus 4i times x minus 4i. Let's see, x times x is x squared. X minus 4i is -4xi. 4i times x is plus 4xi. And plus 4i times -4i is -16i squared. And I'm going to ask you a question, if you can remember, what is I squared? I squared is -1. So this, when we combine like terms, is going to yield x squared plus 16. And again, why plus 16? Because I squared is -1. -16 times -1 is going to give me a plus 16. All right. Now so we've dealt with this, and we've dealt with this, but now I guess let's go ahead and multiply. Trying to debate whether to go to the next slide or not, but I think I will there at the end. Let's go x squared plus 16 times x squared minus 2x plus 1. All right, x squared times x squared is x to the 4th. X squared times -2x is -2x cubed. And x squared times 1 is just x squared. Let's see, and 16 times x squared is positive 16x squared. And 16 times negative 2x is negative 32x. And 16 times 1 is 16. So let's see, let's combine some like terms. So we got x to the 4th minus 2x cubed. Let's see, then we got x squared plus 16x squared. So we got positive 17x squared minus 32x plus 16. Let me jot that down right quick because I got to go to the next slide. All right, ready? Let's go. All right, so remember now we had x minus negative 3 as one of our factors. So that's x plus 3. Now times, isn't this fun? X to the 4th minus 2x cubed plus 17, x squared minus 32x plus 16. Let me write that 6 better. And now we're going to multiply that times x plus 3. Well, let's see. X times x to the 4th is x to the 5th. X times negative 2x cubed is negative 2x to the 4th. X times 17x squared is going to be plus 17x cubed. X times 32x, negative 32x is negative 32x squared. And x times 16 is plus 16x. All right, now 3 times x to the 4th. And I'm going to write these under here so make it a little bit easier so I don't have everything on horizontal. So 3 times x to the 4th is positive 3x to the 4th. 3 times negative 2x cubed is negative 6x cubed. 3 times 17x squared is positive, 3 times 17 is 51, 51x squared. 3 times negative 32x, 3 times 32, negative 32, that's negative 96x. And 3 times 16 is positive 48. And now let's combine like terms. So we got x to the 5th. Negative 2x to the 4th plus 3x to the 4th is going to give me plus x to the 4th. 17x cubed minus 6x cubed is going to give us positive 11x cubed. Negative 32x squared plus 51x squared is going to be plus 19x squared. 16x minus 96x is going to give us negative 80x, and then we got plus 48. So, wow. So if we've got zeros of negative 3, 1 with a multiplicity of 2, and 4i, which also means we got negative 4i as a complex zero, then when we write this function in least degree in standard form, it's going to be x to the 5th plus x to the 4th plus x cubed minus 19x squared minus 80x plus 48. Shazam. That is the answer. I think we should do one more. All right, this time we've got zeros of 2 times the square root of 3. negative 2 times the square root of 3, which, by the way, when we got these square roots, we're going to have pluses and minuses. And then we've got 1 plus I. Well, let's first write this in linear factorization form. So we've got x minus 2 square root of 3, x minus negative 2, square root of 3. We have x minus 1 plus I, and then we have x minus 1 minus I. All right, let's clean up some of our double negatives. So then we're going to have x minus 2 square root of 3. These are going to become positive, so we got x plus 2 square root of 3. And then we've got x, we're going to distribute negative 1 to everything inside there, minus 1 minus I. And then we've got x minus 1 plus I. All right, I probably got room enough on this slide to FOIL x minus 2 square root of 3, x plus 2 square root of 3. Let's see what we get there. So x times x is going to be x squared. X times positive 2 square root of 3 is going to be plus 2x square root of 3. And then we got negative 2 square root of 3 times x. That's going to be minus 2x square root of 3. And then we've got negative 2 square root of 3 times positive 2 square root of 3, which is, so negative 2 times 2 is negative 4. And the square root of 3 times the square root of 3 is 3. So this is going to be 3 times negative 4 times 3. Let's combine like terms. So then this is going to yield x squared minus 12. The plus 2x square root of 3 and the minus 2x square root of 3 is going to cancel. And I think we better move to the next slide. All right, so we're going to have x squared minus 12. We're going to hold on to that for a few moments. But we're going to work with x minus 1 minus I times x minus 1 plus I. All right, x times x is x squared. X times negative 1 is negative x. X times I, positive I, is plus xi. Now let's go with the middle term. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And negative 1 times I is negative I. All right. Now let's deal with the negative I. Negative I times x is negative xi. Negative I times negative 1 is plus I. And negative I times positive I is negative I squared. And what's I squared? Negative 1. So let's combine like terms here. So we got x squared minus 2x. These are going to cancel. I got a plus 1 here. The negative I, positive I is going to cancel. So I got plus 1. And then what is negative I squared? That's negative times the negative 1. Negative 1 times negative 1, that's going to be positive 1. All right, and so when we finally combine all like terms, we got x squared minus 2x plus 2. And now we're going to multiply that times x squared minus 12. Oh boy. X squared times x squared is x to the 4th. x squared times negative 2x is negative 2x cubed. X squared times 2, positive 2, is plus 2x. All right, negative 12 times x squared. Oh, this is 2a. No, it's good. Okay, we're good. Negative 12 times x squared is positive 24 . No, it's negative 12x squared, excuse me. Oh, it's just 2x squared. I was looking for 2x squared. Negative x squared times positive 2 is positive 2x squared. That's where I was pausing. Something didn't look right. All right, negative 12 times x squared is negative, these are fun, aren't they? Negative 12x squared. Negative 12 times negative 2x is positive 24x. And negative 12 times positive 2 is negative 24. All right, let's see if we can combine like terms. All right, so we got an x to the fourth. I got negative 2x cubed. I don't have any more x cubes in there, so negative 2x cubed. I got a plus 2x squared and a negative 12x squared, so that's going to be negative 10x squared plus 24x minus 24. Now, I know I've said stuff like this before, but let me tell you, if you don't enjoy doing something like this, you just don't like math.